In this video, we can prove if the quadratic relation exists between x and y. We can prove the second differences of this quadratic relation will be the same. First, we use this general expression to represent the quadratic relation between x and y. Y equals ax squared plus bx plus c. Here, we need to guarantee a cannot be equal to 0, otherwise, this term will disappear. Then, the left terms will decide the relation between x and y will not be a quadratic relation because this term disappear, just this term left, so it will be a linear relation. So this is the prerequisite for the quadratic relation. If we use this general expression to represent quadratic relation, we can use x1 to get y1. Similarly, we can use x2 get the corresponding y2, x3 to get the corresponding y3. Similarly, x4 to get the corresponding y4. According to the algebraic expression, we can figure out the first difference. We use y2 minus y1. That is to say, we use this expression to minus this expression. This term cancel out, and just this expression left. We isolate the common factor, so inside the brackets, we have this expression. For these two terms, we isolate common factor. Inside the brackets, we have x2 minus x1. Similarly, if we use y3 minus y2, we get the corresponding difference. They will cancel out with each other. A isolated, B isolated. So we get this expression as the first difference between y3 and y2. Similarly, y4 minus y3, we get this expression. Now, we can figure out this term, because x changes evenly. So the difference will be the same. They are equal to one another. But for the first term, we can figure out they will not be equal to one another. Why? First, observe this term. x2 squared minus x1 squared. This is difference of squared. So we use the formula to get the corresponding expression x2 plus x1, x2 minus x1. Because here it is the difference of x2 and the x1. Similarly, for this expression, we can figure out x3 plus x2 times x3 minus x2. Because here they are the same. Because x changes evenly, so the difference should be the same. But for the sum, they are not equal to each other. Because x1, x2 plus x3, they will not definitely be equal to each other. So we cannot get the conclusion this one equal to this one equal to this one. They are not equal to one another. But we can get the second difference. That is say, we need to use this expression minus this expression. This is so-called second difference. That is say, the difference of consecutive first differences. Okay, we use this expression minus this expression because they are the same. So they are equal to each other. So they will disappear. Just this and this left. We have known this one equal to a x2 plus x1 times x2 minus x1 plus b x2 minus x1. We isolate x2 minus x1. We get x2 minus x1 times a times x2 plus x1 plus b. Similarly, for this first difference, we get x3 minus x2 times a times x3 plus x2 plus b. Similarly, for this first difference, we get x4 minus x3 times a times x4 plus x3 plus b. Okay. If we want to figure out the second difference, we need to use this expression minus this expression because we have known this one equal to this one equal to this one. B, they are identical numbers. So we just need to analyze whether this part equal to, not equal to, this one minus this one, right? And this one minus this one. We need to figure out the corresponding difference between this one and this one. So we use this expression minus this expression. You will find out the difference should be a x3 plus x2 minus x2 plus x1. We isolate a. So the difference should be a x3 minus x1. x3 minus x1. If we use x2 minus x1, we get delta x. x3 minus x1, we should say it is 2 delta x. Similarly, if we use this one minus this one, we can get the corresponding. We use this one minus this one, we get the corresponding second difference. The essence is just to observe the difference between this one and this one. You will find out the difference is a isolated x4 plus x3 minus x3 plus x2. So after reorganizing the difference, we get x4 minus x2. Here, this x3 and this x3, they cancel out with each other. So the difference, just x4 minus x2. It is also a times 2 times delta x, because x changes from x2 to x3 to x4. This is 2 times delta x. So we can find out here a times 2 times delta x. Here is also a times 2 times delta x. So we say the second difference, the axis should be focused on a times 2 times delta x. We can figure out this number is a constant. So we get the conclusion. The second differences will be the same number. So we say the second difference will be a constant for the quadratic relation between x and y. This is the algebraic proof for this conclusion.